2 of HEC-RAS Bootcamp. Today should be a pretty short and easy day. I'm thinking we're going to discuss cross-section layout and steady flow data, entering steady flow data, as well as reach boundary conditions, and then a little bit of some tips on keeping your model organized and navigating through a HEC-RAS model. So yesterday we ended up going through the steps of laying out our stream center line, bank lines, and flow path lines that will be used to generate the HEC-RAS geometry. And as I mentioned, depending on if you're building a model from scratch, the next step would be building your cross sections after laying out your cross sections. But since in this case, as with a lot of our projects, we already have a HEC-RAS model that we're starting with, we are going to actually just start with their cross sections is what I did. So they're already here for us. But I wanted to go over a little bit of what you think about when you're laying out the stream cross sections for building your HEC-RAS model and any special considerations there. It's really very straightforward, and in most cases, for most reaches of stream, if there's not a structure there, we just intermediately space cross sections at regular intervals to capture the changes in channel geometry. If we know of a significant like break in geometry where it like changes from one type of channel to another, or you can tell the geometry changes in your stream, then it's important to add cross sections at those locations. Or if the profile changes significantly, you want to do that so that it's most representative. But as far as laying out cross sections, there's only a few rules. And I like to start by thinking of if you had, or the first rule is you draw your cross sections perpendicular to the contours. And so if you think about the most basic stream, let me pull out paint for a second. I'm not sharing my screen again, am I?
Nope.
You would think I'd learn. Okay, can everyone see that? Y'all see that okay? Good. So as I was saying yesterday, we laid out the flow paths, the channel banks, the stream center line, and then the next step would be to lay out your cross sections. So the main rule in laying out your cross sections is to keep your cross section cut lines. So we have an imaginary channel, and let's just say this is a perfectly straight channel. So you can imagine the contours of just a perfectly straight channel are going to be like this, down the bank. So always start there when thinking about how to lay your cross sections. They're perpendicular to the direction of flow. So your cross sections for a perfectly straight channel are just going to be, and then remember, so if this is going downstream, always think like HEC-RAS. So we're looking downstream. So we want to draw from left to right. So we would draw our cross-section cut lines. In case it matters, some software programs will take care of this for you once they know the direction of it. But just in case it doesn't, I would draw them always starting from your left side of your cross-section to your right side. And so in a case of a regular channel like that, it's just going to be straight lines. but often we will have a little bit of terrain to work with. And so in that case, you'll see this is a good example. We just try to keep the direction of our cross-section lines somewhat perpendicular to the contours we're working with. And so like this one, we start out on one side further than we think the floodplain is, and then we would draw it pretty straight here. So it's pretty straight, but when it starts having significant bends like this, we might bend the contour and take it up the hill a little bit. So you just have to think that way, and it becomes second nature once you've done one or two. So the other important thing about laying cross sections is where are your roadway, bridge, and culvert structures. In the reference material for the syllabus, I put this picture in there, which is from the HEC-RAS hydraulic reference manual. So you'll hear people in modeling talk about the 4 sections that you have for any bridge structure. And what that is referring to is what this explains here in this part. If you were to go and read this part of the HEC-RAS manual, you want one at the upstream bridge face, one at the downstream bridge face, just upstream and just downstream of your structure. And then you want another one where flow has fully expanded. So as water is flowing through a bridge or a culvert, there's a contraction to get through the opening. And when we consider that, we want to have one where it's back to normal, and then on the downstream side, one where it's back to normal again. So these, for modeling purposes, for what we do, just assume this contraction reach 1-to-1 here. So when you're figuring out how much you need to go for your next cross section, and a lot of times it's not critical to be to the nearest foot. You just want you want a cross section right at the bridge face, and then you want one slightly upstream of it where most of the contraction will have taken place. And then we'll talk about this a little bit more when we talk about ineffective flow areas later this week. But the other one is on this side, and on this downstream side, always take this to be 2 this way to 1 that way. Now, it can vary, and you get into the manual, and it probably goes into a lot more theory and things to figure out about what this might be, but those are good general rules of thumb to use when laying out, and it's good enough for what we do. We are not scientists. We are engineers, which are figuring out like practical solutions to problems. We're not expected to be like studying these to the gnat's hiney, we just need to use some general things that work pretty well and be able to get the answers we need for a project. So what else on cross sections? So looking at this project, I know the survey is not very great, so it doesn't show things too clearly, but we have this roadway here, and there's a set of culverts here. So when I was doing this corrected effective model, one thing I wanted to make sure was I had a bridge face cross section for these. So this stream kind of winds its way down here and then goes under this main bridge. So what I did was draw in one at this face. So I started it at the end of the section and then drew it there. Then across the channel and then back up to the floodplain the other side. That happens a lot when you have roadways. You're basically usually just the roadway creates a berm, so your cross sections start to like on the downstream side start to run parallel to the roadway. So I drew one there. That's close enough to being the expanded out, the fully expanded flow on the upstream side. I might have something I want turned off. As I'm looking at it more, I probably want one. We also have the creek going through these bridges, and even though they're high, I probably want one more at this bridge face, which will have a double purpose of being the fully expanded flow for this one, and then also the bridge face for that one. So it's not always as cut and pretty as you see in this picture here, and that we have multiple structures. So, but the concept is the same. So as long as you're thinking about this when you're laying your cross sections, you'll probably be good. So that's really all I've got to say about cross sections. Does anyone have any questions on that part?
So do you have like
I had a question.
Oh.
Yeah.
He typed one.
Oh, someone typed one.
I was going to ask, did we have like a minimal amount of cross sections that we're looking to have at least with those 4, or is there?
So whenever you have a structure, at least you put in the ones at the bridge face and then ones where it's expanded out. As far as spacing in here, probably if I had gotten their cross sections, these are straight from BGE's model, and they just had one here and one here, one here, I wouldn't have batted an eye. I would recommend just looking at a few models to get a feel for the spacing relative to the width of the floodplain. So as the floodplain gets wider, your spacing gets farther apart usually. And yeah, main thing is if you have a change, then you want to add a cross section there. So maybe if you're looking at, if we could go through the exercise of just where'd my paint go? So we have imaginary stream that's going straight, bends again, straight. You would probably want just some regular amount of spacing here, and then you would want, like, say this might indicate a big change in geometry. You would want to capture a few where that happens and then come back out. So if your channel is pretty uniform, think about what we're doing. Like if you have a uniform channel that's trapezoidal, I cannot draw that well, but that's supposed to be like a sectional view there of a trapezoidal channel going downstream. Can y'all make that out? So if that was perfectly uniform, had the same flow throughout, we know we could get the answer with just HEC RAS. It would tell us not HEC RAS, just Manning's equation to figure out how deep that is, because it's uniform flow. And so if you have like pretty similar looking geometry, then you don't need to be spacing a ton of cross sections. It's usually something a little bit like this visually, to where it's not like you're just slamming cross section after cross section after cross section. It's something similar to the width of the cross section is how long it is, maybe a little bit less. So if I had a uniform channel for 1,000 feet or 10,000 feet, the height of the water would still be driven by Manning's equation. So it's only when you have a lot of changes that you really need to make sure you add additional cross sections. Does that make sense? So it's an eyeball thing, really. When it gets out, like, look at a few, see what they did, and space them out, and you're probably going to be good. Like, because it's not, having more is not going to change the answer. If I had 100 cross sections in here and the channel is doing the same thing, it's not going to really change the answer. It just might create more work for you. So. What about you, Elise? Did you have another question?
I didn't have a question, but did you answer Adnan's question?
No, I'm not seeing what's going on in the chat here. How do I hide the stream?
The chat is the bubble, yeah, right there. Click on
There
that.
we go. Why do we have multiple cross sections around the stream? Could you clarify that question, Adnan?
So basically, we're taking cross sections only at places along the center line of the stream, the pink line. That's the cross section, right? So those
Pink
are
lines.
only going to be at those places where we have like structures, right? Or
we will have it just regularly across the stream, even when there's not a structure, but especially when there's a structure, we want one right upstream and right downstream of it.
and you mentioned that we are going to draw it from left to right, but we have to look at the downstream.
Yes, so this stream is flowing from the top of the page to the bottom, and when you think of left to right, you're looking downstream. So imagine standing here and looking down this way. So this becomes the left side, and I would draw it in that way. If you did it wrong, you would find out, if you drew it the other way, your cross-section data would come back, and you use the software that doesn't compensate for you. Your cross-section data would come back with negative numbers on the station. So that's how you would spot that. Like when you go, I have 3 screens open and it keeps hopping to the far right screen on my computer. I'm like, no, stay. So this is your left of bank according to the model. If you were to run it with your lines drawn reversed, it would probably come in with these being negative here and all this being negative. So it would be annoying. I don't know that it would change. I don't know that it would really not be able to run or anything. It just would be stressful for most people to see all these negative numbers and have to work with those. So.
And where do you get the downstream reach length and like that particular data, like the Manning's value? Is that something you're also getting from the
okay,
drawing?
so these here that I'm highlighting.
Yes.
So that's I don't know if you had a chance to listen to yesterday's, but and we'll we're going to do this on Friday. That's going to be the exercise, is we'll build the model. But when we drew in these flow path links, and these we were trying to space 1/3 of the way between the bank line and the edge of the cross section, or the bank line and the floodplain. Either one will get you close enough. These lines are what HEC RAS, and when we create a geometry from it, it's going to take the length along this line to find those reach links. And for the main channel, it's going to use your main channel line that we have and calculate it that way. So that's a good thing about using these tools, is it generates a lot of that for you. And then we'll still have to think about Manning's in values. And we'll go over that a little bit later this week, but you'll still have to pick your Manning's in values for the cross section. But
so for each data point, the LOB and the ROB is different, right?
yes, for each cross section, yeah.
Okay.
So
Okay.
yeah, that's how you can tell that they did a similar process to calculate these. So, but that's really all there is to cross sections, or the basics of it. I did link a few articles that are probably worth reading at your leisure that might answer some more technically sound than I did about how we can usually eyeball it, which is true, but it'll give you some background on what they say of like spacing your cross sections and some of those things, when to put changes. So this model, for example, this is about as upstream as we care about on this one, because our project is right here. If I was to continue that on, we have another structure here, so it would be a little more concerned about putting that on the face, and that would probably still be good, but then having another one up here and then doing that. So you just identify how many structures you have and make sure you've laid out your cross sections adequately to add the bridges into the model, which we will also look at later this week. But the other thing I wanted to cover today was some basics on just being in HEC RAS itself and then entering steady flow data. So if I open a project, I'm just going to open this project in HEC RAS. In general, you're going to want in order to get the program to run, you need a geometry file, which is what this geometry data shows you. And then you need flows for that, which is this running man here, the steady flow data usually. There's also options of doing unsteady analysis and stuff like that. That's less common. We're not going to get into that this week. But for your steady flow data, it's this guy here. Actually, I'm sorry, that's not your steady flow data. That's your really your navigating tool. And what that shows you is, like I said, we have two things. We have a geometry file and a steady flow file. And this tool is your friend for navigating through the model and not creating a messy model. And I'll explain that a little more. So I wanted to show you, so it's got this plan. A plan has a geometry file and a steady flow file tied together. So for this one, we've got the geometry corrected effective existing and corrected effective existing for the steady flow data. If I wanted to open another one, I would use this plan to navigate. And where did it go? So I say file open, and it pops up the very farthest side of the screen that it could possibly pop up at. And say I want to go back to the original existing. So I would go here. And that keeps, what that does, it keeps the geometry file and the associated flow file that it was intended to keep together. So a mistake people can make is there'll be in this existing geometry and they'll say, oh, I want to see the proposed. So I'm going to make that mistake for y'all. If I do that here, I'm going to disconnect. No, I'm not going to do that. So if I just open the proposed geometry, it messes up the plan that someone already created. And this, like, you could have, you in the course of your HEC-RAS modeling and all the things we might experiment with, we might run different scenarios. You could have 20 different geometry files, but in general, only 2 or 3 of those will be of any use to you. So when they are of use, we usually save a plan. So we tie it with the correct steady flow that it should be tied with. But if you navigate this way, which, you know, if you didn't know any better, you might easily go into the geometry data file and then do that. You've kind of messed up and made this model a little bit messy. So I'm going to open this plan. I'm going to say no to that so that it doesn't save that disassociation that I did where it's got the proposed geometry with the existing flows, which we don't want. And I'm going to go back to the corrected effective existing. And that's got the corrected effective existing geometry with the corrected effective existing flows. And that's what I want. So this is how HEC-RAS keeps things organized. In general, when you're done with your modeling, you want to have maybe 2 or 3 plans. You want maybe an existing or effective, and then corrected effective where we fix that, and then a proposed. Like it could, you may be running scenarios, so you may have more useful ones, but in general, when you're submitting a project, it should only have a few. But you might have, for this bridge, I might have looked at it for the bridge group, may have had me look at 75-foot span and 150-foot span. So I could have like 10 different proposed geometries, but the plan navigation you want to keep clean. But I'll also say that in the beginning, it's not as critical. Like right now, I'm kind of messing around with the model. I know all this is going to change. I'm not anywhere close to finish, so I may accidentally make the mistake I told you not to make because I haven't set all this up yet completely. So the steady flow data is actually here. This Q equals, and it's really simple. So that's the other thing you need. That's generally going to be something we get from our HEC HMS model or drainage area map that is looking at the stream you're modeling. So for this case, I would come into the steady flow data. I have them in the spreadsheet, what I want the flows to be. I don't know that I've put them in there yet. Actually, I did yesterday. So, but if I were to change that, I just double click on them and it lets you change them. If there's not enough, then you can edit the number of profiles you have. So this one has a 2, 5, 10, 25, 50, 100. So that's determined by this. And then the other thing to look at, the other thing that affects the model is your reach boundary conditions. And that is here. 99% of the cases of the models we work on, we're going to have a normal depth boundary condition. And that's going to be driven by the slope of the channel, the approximate slope of the channel at your downstream end. I haven't checked their data yet, but it would be, you know, what's the general slope in this area? And we would probably do that by looking at a longer reach than in this case, because as you can see, like cross sections can be a little bit messy. Like these elevations, it's doing a little bit of up and down, which is fine when you cut the cross sections. But if I looked at this over like a 2,000 or 5,000 foot stretch, what would this slope be approximately? And that's what I would enter in as the normal depth. So if I double click on that, that's in feet per feet, and you would put that in as approximately what your downstream slope of channel is. Does that all make sense? I think that was all the material I had to cover today.
Are those structures overtopping? What are those two structures in front of the bridge? The front and
Yes,
downstream of the bridge.
those
roads?
are yeah, I think that is the frontage road structures that they had in the original model. So that elevation is much lower than the main lanes, and it was overtopping in all the events, it looks like.
Are we gonna at some point in time go over entering the data in by Friday?
Yes.
Because
For,
I'm saying,
for these culverts?
yes, like no,
Yes.
for the stream,
The
like
cross-
say
yeah,
my
they-
cross sections. Say you needed to add one. We're like, I don't like the model they originally had. I need to add another cross section into my data.
Oh, into your data? So,
Yes,
okay.
say like they missed a spot, and I think this is important.
So just what's, so we have it all drawn in what we want to create, right?
Mm-hmm.
And I'll just give you a sneak peek. So what you end up doing is we have a surface in here, and we draw in what we want it to generate. And then HEC-RAS lets you go file from ORD. I'll show you that on Friday. It lets you export the data. And then you go in here and import the data. And where did I put it? Dun, 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 dun. Oh, this thing pops up. I'm in US customary units. I have a blank geometry, so it's saying you got a new stream, and then it sees all these cross sections, and it asks me if I want to import them in. So if I were just adding one, I could just add one in. Or if I want to import over it, it would also, if I had started with the other data, it would let me like see if I want to revise it. So, but basically, bam, like that's how quick the step is for getting the stuff into what we're doing. Now, a lot of times, like this time, I'm kind of verifying what they did. So I drew these cross sections over it and I added a few in. What I'll probably do is import just these few in and then keep the other stuff, like have this. Actually, I already have this in a spreadsheet, and then manually copy and paste what I want to change in their model over it. But creating the geometry is that simple. And then with that, like it draws in the bank lines off of what we drew in, and it calculates the reach lengths off of what we drew in. It doesn't know what the end values are, so we would have to look at our habitat and figure all that out. But yes, so we will get there. Is that what you were wanting to see?
Yes. Thank you.
No problem.
And the output of this model, what would that be specifically?
The output, so for that, I'll go to one that's already set up. So let's do this. This one. So that is going to be with this running man that is our friend. Helps us navigate the model. If you hit the compute button, steady flow data contains data. Yes, someone apply that data. Computes. It just ran on my other screen. And there's a lot of options. Generally, I show standard table 1 in the plans. And a lot of times we'll also show these bridge tables. Have these in our plans, and it allows you to copy to clipboard and put these into Excel and then bring them into your plan sheets. If it's a really long stream, I may take it into Excel and only show like a certain length upstream and downstream of our project and show how the water surface elevations proposed are tying in close to what the existing are.
And we also show the graphic of the profile, no?
Yes, yeah, usually we also show this graphic on a hydraulic data sheet and also this one, which we'll get to, which shows like the upstream bridge face, and just kind of copy that image and put it into MicroStation so that they can kind of see what's going on. But any other questions? Is everyone following so far? As far as like today, we just covered laying out cross sections and steady flow data. Is that all making sense?
Yes.
Okay.
I guess when you were adding the steady flow data, in that window, it shows like one station, but I'm assuming
Oh,
it just
yes.
applies it for every single station along that stream. Is that correct?
That's a good point. Let me look back. Steady rows over. Okay. So in this case, you always need one at your most upstream cross section.
Okay.
And this is short enough that we're basically just using the flows from one of the drainage areas on our drainage area map, or one of the, actually one of the junctions in our HEC HMS model. If you have a longer stream that you're modeling, like we will for 8 Mile Creek, where we're modeling like 3,000, 4,000 feet of it, you might have a few flow change locations. So if I wanted to add a change in flow at any station here, like at 1116, say the flow, say another tributary comes in and I know the flow is going to increase, then I could come here, select what cross section I want, add that flow change, enter those flows in.
Okay, cool. Thanks.
So if I don't want that, I can delete it. So
Okay. So you will search for your upstream station on the river, add the flows at the
yes.
beginning. Okay.
Yeah, and that will be automatic when you do a steady flow. It'll always pick the first one to make sure it has flows in the stream. But if you want additional ones after that, you can add as many as you'd like.
Okay. Thank you.
No problem. Thank you. Alrighty. Any other questions for today, or? Tomorrow we will talk about bridges and culverts. So hopefully I can get to a little bit more of what I was working on I-20 so I can show y'all a good example of this. But yeah, we'll show some of how to, now that once you have your geometry, how to input a bridge or a culvert that you may have crossing your stream. So that's what we got to look forward to. Alrighty, well, y'all enjoy the rest of your day, and I'll try to put this up on YouTube later.
Thank you.
Thank you.
You bet.
Bye.
Bye. See y'all.